So now we've talked about two different types of randomization. In Chapter 2, our goal was to generalize to the population, and in that case we needed random selection. So the goal of random selection is to get a sample that is representative of your population. So in some situations it's not possible to actually get random selection, but if you want to generalize to the population, you at least need a sample that's representative of the population. So I'm going to say you need random selection or at least a representative sample. Whereas to establish cause and effect, we need a new kind of randomization, random assignment. And specifically, random assignment would take place in a comparative experiment. So you're randomly assigning people like to multiple treatments or a treatment control, something like that. And the benefit of random assignment is that you're creating two groups that are comparable to each other. The idea is the only difference between the two groups is which treatment they received. And if that's the only difference between them, then you can actually say that the treatment caused the response. In other words, random assignment prevents confounding. So in situations where you don't have random assignment, it's really difficult to make cause and effect conclusions because you would need an argument against all possible confounders. And that's going to be really difficult to do in practice, to figure out what all the different confounding variables could be and to convince your readers that your groups actually are similar in terms of those variables. That's going to be really difficult to do. So that's why we think of random assignment or randomized control trials as the gold standard for making causal conclusions. So yes, it's true that correlation is not the same as causation, but that doesn't mean that causation is never possible. We just have to have a well-designed experiment to collect that type of evidence. I also don't want to make it sound like experiments are better than observational studies in every way. That's not necessarily true, because if you think about experiments, you're going to have necessarily sort of a limited design. Maybe it's taking place in a laboratory. It may not be very generalizable, or it may not be very realistic. So in those cases, having observational studies can add necessary information. So in the real world, we're not going to, quote, solve anything based on one study usually. We're putting together information from a lot of different studies in order to address our research question.